What's up, Tea Cats? Dylan here from Moo Mountain Tea, coming at you with Chapter 6 of the Masterclass on Tea, where we are talking about the effects of tea consumption on human health. The information that we present today in this chapter is mind-blowing. There are so many different molecules in tea that have so many different unique effects within the human body. We're gonna be talking about some of my research and the research of other tea scientists that have gone in and investigated what tea does and how it interacts within a living system. So as we start with every chapter, I'm gonna give you the one-sentence summary of the content of this chapter. It's gonna give you a little bit of a framework as we're diving deeper and deeper into today's chapter. So the one sentence summary of chapter 6 is human health promoting phytonutrients in tea include tea polyphenols, alkaloids, free amino acids, polysaccharides, pigments, and more that affect human health across the intestinal barrier through their antioxidative, anti-inflammatory, and stress-reducing effects, as well as outside of the intestinal barrier through their digestive enzyme inhibitory and gut microbiome modulatory effects. That gives you a quick look at what's coming in chapter 6 today. Next, we are dissecting this sentence, breaking down the details, and absolutely flinging you out of this video with a crystal clear, rock solid understanding of the effects of tea and tea consumption on human health.
会把这个传统茶文化带回去美国，在那边推广一下。
Some people out there have claimed that tea is a cure-all for just about anything under the sun. While on the complete flip side, you have people who have said that tea and the phytonutrients in tea have no effects on human health. If you're just looking at what the scientific data has produced about the effects of tea on health, both of those opinions are completely wrong. So what we're gonna do today is just stick to the science throughout this conversation of tea and health. So most research says that there's about 100 total bioactive compounds in tea. Now you'll remember from chapter 2, we introduced the 3 biggies, right? We got tea polyphenols, mostly comprised of catechins. We have free amino acids, the main one being L-theanine, and we have alkaloids, the main one being caffeine. But of the bioactive compounds in tea, we also have tea polysaccharides, saponins, different mineral elements in tea leaves too. And all of these different bioactive molecules together and individually play a role in affecting the cells and systems in our body. Now, any good science-based conversation about tea and health needs to start by addressing the issue of bioavailability. Say in my cup of tea here, I have 1,000 EGCG molecules, right? That's the main catechin, the main polyphenol in tea. So of the 1,000 EGCG molecules in this cup of tea, when I drink it, how many of those EGCG molecules are passing through the intestinal barrier and getting into my bloodstream and eventually to the cells, tissues, and organs in my body? And that's extremely important because it's one thing if you're looking at EGCG in a petri dish, but what we want to know in terms of the impact of tea and health is how much is getting into my bloodstream, right? So with certain molecules like caffeine or L-theanine, these are extremely bioavailable. When you drink it in a cup of tea, almost all of it gets into your bloodstream, and with caffeine and theanine, it gets to your brain. That's why you can feel the psychoactive effects of these molecules. But other compounds in tea, specifically those tea polyphenols, are much less bioavailable to us. Within the GI tract, before we absorb them across the intestinal barrier, they get broken down into these little bits and fragments and pieces. And that mostly happens by the interactions of these polyphenols with the microbiome in our gut, with the billions and trillions of bacteria and fungi that inhabit our GI tract. And we're gonna talk about that way more in detail towards the end of this video. But for now, it's important to know that they are breaking down these polyphenols, and therefore it decreases the bioavailability of that whole EGCG molecule. So in the past, right, in the beginning, I was saying that some people have said there's no actual effects of these bioactive T polyphenols, because they saw that if you measure the amount of EGCG in your bloodstream after drinking a cup of tea, out of those 1,000 EGCG molecules, you're only seeing like 20 or 30 in the bloodstream. So that's a super low bioavailability. But that is actually not the full picture here. So when the molecule is broken down by the gut microbiome, they form these little fragments, these splinters, these pieces of the former parent molecule. These are called polyphenol metabolites. So yes, we don't have whole EGCG molecules crossing the intestinal barrier often, but we do have a lot of these metabolites, these breakdown products of EGCG crossing the intestinal barrier and accumulating in the bloodstream at levels where they're relevant to affecting human health. And when you account for these metabolites in the bloodstream, the bioavailability of EGCG and T catechins increased tenfold, 10x the amount of T catechins in the bloodstream that we used to think was there. That really changed the game, and that created this whole new research field where it's like, okay, what are these metabolites doing? Do they have the same antioxidative and anti-inflammatory properties that the parent EGCG molecule does? That's the question here. So now I want to show you a table produced in 2019 by my favorite T science researcher, Dr. Keiko Ono. I'm such a fan of her work. I actually flew to Japan in 2018 to visit her lab and see what she's up to because I was tracking her research and they were doing really cool stuff over there. We're going to dive into it a lot more in a second, but I want to show you a table produced by her in 2019, which shows you on the left here, you have all these different T catechin metabolites, right? These are the breakdown products of EGCG. In the middle, you have the various bioactive functions that they've been shown to have. And then on the right, you have the references, right? The original research that showed that these catechin metabolites actually have these functions. So you can see that when you break these T catechins down, then the metabolites, the breakdown products of these catechins are still extremely bioactive and doing basically the same functions in the body as the parent molecule. And this research is so important because these metabolites are really, at the end of the day, what is getting most into our bloodstream. And so understanding these metabolites is kind of the key of researching the effects of tea on health. For the sake of this video today, what I have done is divided the health effects of tea into two main domains, two categories, inside of the intestinal barrier and outside of the intestinal barrier. So let's start with when tea crosses the intestinal barrier. The brain is the organ I wanted to use for this across the barrier example because there's actually a second barrier that separates your brain from the rest of the body. And it's called the blood-brain barrier, the BBB. Basically, if molecules can not only cross the intestinal barrier, but also the BBB and get into the brain and have effects on neurons in the brain, then they can get anywhere in the body, right? So it's the ultimate example of like, if T catechins and bioactive T molecules can do this, then they can essentially do anything. So let's run through like 2 or 3 minutes of bioactive T compounds entering the brain and interacting with neurons. So in another one of Dr. Uno's works, she showed that with a BBB model, the T catechins and their metabolites do cross the human blood-brain barrier, and they interacted with human neurons to induce neurogenesis, which is actually the growth and the outbranching and outreaching of neurons, which is extremely important because it's the deterioration and the lack of growth in these neurons that is the underlying mechanism of neurodegenerative diseases like Alzheimer's and Parkinson's. In these diseases, you have the decaying and lack of growth of these neurons, which to date we have really no remedy for. There's no good cure for these diseases to date, but Dr. Uno in her work showed that T catechins and the metabolites, importantly, of these catechins can actually act on these neurons to induce the growth and outbranching of new neurites, which is really cool, right? Obviously, this doesn't say that tea is a cure for these diseases, but it's a very, very interesting indication. It's a very interesting finding that suggests that there could be a role to be played here by these T catechins in these various brain diseases. All right, so another one, we have experiments in mice that have showed that when you feed mice EGCG or EGC, these are two primary T catechins in tea leaves, they found that there was far less lipid peroxidation in brain tissue. And lipid peroxidation is the main form of oxidative stress in cells. So that basically showed that by ingesting orally these T catechins, it did cross the intestines, then it crossed the BBB, and it was able to act as an antioxidative agent, an antioxidant within the brain. Of course, it's mice, right? It's not humans. And it's important to say that we don't have much research about the effects of T in the brain of humans because it's extremely difficult to biopsy brain tissue from a human. There's huge limitations on studying the effects of these compounds in the brain of humans, but in mice, it did have the effect of reaching the brain and having significant antioxidative effects there. We also see significant anti-inflammatory effects. The anti-inflammatory effects were shown where you give mice lipopolysaccharides, a molecule that's on the surface of bacterial pathogens. And over time, animals have evolved these really strong inflammatory responses to this molecule because it indicates that there's a pathogen in the body and we need to get rid of it ASAP. So in the brains of mice that were fed LPS, the ones that were given L-theanine or T catechins ahead of time had way less inflammation in the brain tissue, way less neuroinflammation, as it's called. So both of those bioactive molecules from T showed significant anti-inflammatory effects in brain tissue of mice, which is really interesting because neuroinflammation is extremely detrimental and causes a ton of damage in the brain and can actually contribute to the decay and the loss of the integrity of those neurons and lead to more of those neurodegenerative diseases that we are just talking about. Now, on to maybe my favorite and what I think might be the most interesting effect of T in the brain is the anti-stress effects of T-free amino acids. And the big ones are L-theanine and arginine. And this is more of the research from Dr. Uno from Japan. Basically, these free amino acids in the brain, they bind to AMPA type glutamate receptors. That causes a release in glycine, which is the main inhibitory neurotransmitter, second to only GABA in the brain, right? Those are the two main inhibitory neurotransmitters. And when you have those released, it just calms you down and makes you feel good. Alcohol, for example, the sedative calming effects of alcohol comes directly from GABA released into the brain. So glycine is really, really similar to GABA and its effects. So by binding to these AMPA type glutamate receptors, glycine is released, and that in itself, like we just said, feels good, but glycine released into the brain also releases dopamine into the brain, which also definitely enhances mood and makes you feel good. And what Dr. Uno did, which is really cool, is that she likes to conduct experiments on her undergraduate students. So within the College of Pharmacy in Japan, there's at year 4, you have this huge examination, and it kind of determines if you graduate from pharmacy school and if you're able to become a pharmacist. So it's a huge amount of pressure and stress on these year 4 students. And so she conducted an experiment where she had a no T group, she had a normal T group, right? A normal ratio of catechins to amino acids, a normal TCAA ratio, which you'll remember from chapter 5. And then she has a third group, which is elevated amino acids relative to T catechins in the T. Again, from chapter 5, you'll remember that's kind of like the higher quality Ts oftentimes will have a lower TCAA ratio and more of these free amino acids in the Ts. So she had those 3 groups. She was taking samples over a multi-week period of time leading up to the big examination. And she found that in the amino acid rich T group, they had significantly less levels of salivary cortisol than the control group and even the normal TCAA ratio group. So that was fascinating. I thought it was really cool because it showed that T not only was better than no T, but also this amino acid rich, higher quality T was better at reducing stress than just the normal TCAA ratio T. So in a word, consuming good T literally makes you less stressed out. Okay, so let's do a quick summary of T in the brain. We got T crossing the BBB, entering a human blood-brain barrier in vitro, inducing neurogenesis, the outgrowth of new neurites out of neuron cells. We have catechins and L-theanine that's ingested orally, crossing the intestinal barrier, entering the brains of mice and causing less oxidative stress, having antioxidant effects, causing less inflammation. And in humans, mice, and all of these models, we've seen that there's significant anti-stress effects particularly of the free amino acids in tea. That is just a slew of awesome neuroprotective, brain health promoting effects of free amino acids, polyphenols, and caffeine as well. You'll remember from chapter 2 when I brought up caffeine, there are a ton of really interesting long-term effects and benefits on the brain of moderate daily caffeine consumption, right? Obviously, caffeine should be taken in moderation, right? It can affect sleep, but a small, moderate dose of caffeine has also been shown to be super neuroprotective and obviously enhances mood, cognitive performance, etc. So all these different bioactive molecules in tea, getting in the brain, doing cool stuff there. I love it. Now let's take things out of the brain, out of the body, and back outside of the intestinal barrier. Okay, so outside of the intestinal barrier, we have two main ways, two really important ways that bioactive molecules in tea can impact health. And one is called digestive enzyme inhibition, and the other is by modulating and changing the gut microbiome. And both of those are extremely important. So let's start with the first one, digestive enzyme inhibition. Say you head on down to your local Shake Shack and you get yourself a big greasy cheeseburger and you wash that puppy down with a big tall chocolate milkshake. So that is a massive load, an ungodly amount of fat and sugar that is sitting in your intestines. Now the fat and sugar in that big greasy cheeseburger and that milkshake don't just hop right across the intestinal barrier willy-nilly. They need special digestive enzymes excreted by the cells in your intestines to break down that sugar and break down the fat into more easily absorbable forms. It's called fat emulsification. You're taking the fat and you're breaking it down into smaller little globs that you can then break down more easily and absorb into your body. Now, tea interacts with those digestive enzymes. So the digestive enzymes that are responsible for breaking down that fat and that sugar, the molecules in tea, specifically the tea polyphenols, they actually bind to those digestive enzymes in really critical sites on the enzyme that affect the function of those enzymes. So those digestive enzymes are less able to break down the fat and sugar that you just ingested from that greasy cheeseburger. What that means is that, say you have cheeseburger by itself, and then you have cheeseburger plus really tall glass of green tea. In cheeseburger alone, you're gonna eat that, and say, for example, you're gonna absorb 100% of the fat and the sugar that's in that cheeseburger. If you pair that cheeseburger with a big tall glass of green tea, you are gonna only absorb maybe 70 or 80% of the fat and sugar from that big greasy cheeseburger, because the polyphenols in the tea are stopping those digestive enzymes from breaking down the fat and the sugar into smaller, more absorbable forms. This is called digestive enzyme inhibition. And these polyphenols inhibit lipase, glucosidase, amylase, these big fat and sugar degrading enzymes. So that is a massive, important feature and function of these tea polyphenols, is their ability to inhibit digestive enzymes. That has direct implications for weight gain, obviously, but also things like that postprandial spike in glucose is way lower if you're eating your high sugar foods with polyphenol rich teas. You have mitigated risk for obesity, metabolic syndrome, type 2 diabetes, right? All of these things that are triggered and caused by too much fat and too much sugar in the diet. The ability of tea polyphenols to do this and reduce the amount of these fats and sugars you take up can actually be extremely important in delaying or stopping the onset of these terrible diseases, right? Okay, so let's now move on to this other type of out of the intestinal barrier effect. And this is the modulation of the gut microbiome. Now, the gut microbiome is the coolest frontier in health science research. Throughout our whole mouth, all the way out to the other end, you have this insanely vast community of microbes. There are 10 times as many microbial cells in your body as your own cells in your body, which is insane. And these microbes have incredibly important functions in digestion, immune function, even mental health, brain health, right? In recent years, we've discovered this thing called the gut-brain axis, where specific microbial populations can produce serotonin and enhance the amount of serotonin in your own brain, which makes you feel better. It enhances your mood, right? There's a role of these microbes in your own mental health, which is just mind-blowing. These microbes in your body are absolutely essential to health, and your microbes are eating what you eat. And when you feed yourself, you're also feeding your microbes. Doctors and practitioners of holistic medicine in recent years have started to kind of say that the best way to support a good microbiome is by eating the rainbow. And that basically means on your plate in any given meal, you want to have as many colorful plant foods as you can, right? Throw some heirloom carrots on that plate, get some zucchini, get some squash, get some, some purple cabbage, right? Mix it up, and that diversity of colorful plant foods is really what helps to cultivate and feed those beneficial microbes in your gut. Well, with tea, we're not eating the rainbow, but we're drinking the rainbow, right? Think about the rainbow. We got Roy G. Biv. Red, we got black tea, right? That rich red soup of black tea. Orange, we got oolong tea and white tea or raw pu'er. Yellow, right? That's less oxidized oolongs or yellow teas and green teas kind of, right? G, we got green, blue indigo. Not many teas are blue and indigo, but violet, right? We have tons of interesting tea cultivars that have really high abundances of these anthocyanins that are what create that purple coloration and blue coloration in blueberries, for example. And it's actually the same concept here. Those colorful plant polyphenols that provide their rich colors to these different food sources that are supposed to be in your diet are the same polyphenol pigments that are in teas that give them their distinctive colors. And that's why I always tell people when they ask me what's the healthiest tea to drink, and I say, well, diversity is probably most optimal, because by drinking green tea in addition to black tea in addition to white tea, you are providing your gut microbes with as many different polyphenol pigments and these bioactive tea compounds as you can. They're finding that people who incorporate these various tea types into their diet have really healthy microbiomes, and that translates, as we mentioned, into all these different aspects of health: immune function, mental health, cognitive performance, etc. That is another example of tea-mediated health effects that don't even require the tea crossing the intestinal barrier and entering the bloodstream. It all happens right in your gut. So that is really, really cool, but a lot more research to do because the microbiome is so complex. There's so many different communities and they all interact with each other, as well as your own cells, as well as the foods that you're feeding them through your diet. So that has just been an insane amount of information thrown at you. I don't want an information overload to inhibit your digestion of the information we already have. Did you see what I did there? We only scratched the very, very, very surface. I would love for you to comment and tell me what other aspects of tea and health would you like me to explore with future videos, right? We have tea and weight loss, more about the antioxidative effects. We have anti-inflammatory effects. We have specific organs, right? What are the effects in the liver or blood cholesterol levels or skin health or cardiovascular health we didn't even touch on today. In chapter 7, we are getting into the long history of tea as it has traveled around the world. We are stepping out of the hard sciences for a little bit, and we are just talking about tea from its discovery in ancient China all the way to today. And the history and the spread of tea over time and space is so interesting. The things that the tea leaf has seen and the human civilizational events that the tea leaf has been a part of just never cease to amaze me. For now, if you liked chapter 6, give me a like. Would love for you to subscribe to the channel if you haven't already. Share the video, comment below. Many, many ways you can support Wu Mountain Tea. More importantly than everything else, I want you to 1, stay healthy, 2, stay positive, and 3, keep sipping tea.